Let me check if my pen is working. Okay, it's working. All right. Who have been part of the earlier course that I had, which I think an academy is a great platform, to learn new things, especially in today's time, where a platform like Unacademy gives you access to to a lot of knowledge, right? People with knowledge, you can that are available to share that knowledge with you all, right? So I see somebody else also has joined, Josmi. Okay, hello Josmi. Okay, so let's just move forward. So a lot of credit goes to Swami Bharati Krishna Tirthaji. He basically, over a period of 7 years, he was in solitary, on a journey of learning more about mathematics. So he had a lot of different knowledge. He knew physics, he knew astrology, he knew science. Of course, he knew mathematics as well. And then yeah, good, Josmi. See, I think this class is good introduction to Vedic Maths. I will give you a few. We'll solve a few problems, and then you will see the power and benefit of Vedic Maths, and you will wonder for yourself that why didn't I learn this before, right? And it's very simple, common sense, nothing else. Okay, I discovered this in the last 2 years only, and I found out that it is nothing but simple common sense. Okay, and it is a very intelligent way of doing problems. Okay, mathematical problems, solving problems. It's a very intelligent way. If you have, for example, in conventional maths, you will probably solve it in 5 steps. In Vedic Maths, you will solve it in max 2 or 3. Mostly, it is 1 or 2 steps. Okay. Hi, Kashish. All right, so a lot of credit goes to him, and ultimately it is based on 16 sutras or word formulae. I'm not going to make you by heart any formulas or anything. It is going to come very naturally. Okay, that's the whole idea. All right. So some benefits. My favorite and most benefit is this. It increases your flexibility. You will have different ways of solving a problem. Okay, and I will teach you different methods. We'll not be able to go through all the methods here because we are only doing a 1 hour course, but it will give you a good introduction to some of the methods that we will use. Okay, and of course, mathematics was not really my favorite also, but actually, of course, I had to learn and all that during my my education time and all that. But as I am in a corporate world for the last 20 years, I have realized that numbers is the most important thing, right? You cannot survive without numbers. You need to be good at numbers, and if you're good at numbers, you will also have ability to convince others very quickly, right? Everybody is very alert to hearing numbers, right? And if you are able to convey that message quickly, you will be always at an advantage. So numbers is going to give you for the next, assuming you're all in the 6th to 12th grade, you still have another 20 years ahead in your good professional life, right, where you have a lot to make use of it. Okay, and the most important thing is, Vedic maths extends to algebra, geometry, calculus, trigonometry, coordinate geometry, and a lot more. In the courses that I have done, we have only focused on arithmetics, a little bit of Pythagoras theorem and all we have done, but there is a lot of benefit to that. Okay, so we are going to cover these three things today. Okay, subtraction, accelerated multiplication, and one line division. This is what how can one count money if he's not familiar with numbers? Yes, that's why. Yes, absolutely, right. So obviously, to live, a very high quality life, we all desire to live a good quality life. Money is not the only thing. A lot of other things are also there. But everything in life is a balance. It's a balancing act. Okay, so it's like this triangle. You will have different forces up. Life may, whether it's your professional life or your family life, everyone will pull you in different directions. You try to balance it out. Okay, so let's start with subtraction today. We'll go to multiplication and we'll quick look at division. I hope we have the time, so that's why I'm just little bit of going a little fast here for the first 9 minutes now. Okay, so some very basics in Vedic maths is something called the base and complement. Okay, listen to this very carefully. Okay, something called the base and complement. Okay, so base numbers, when I mean base numbers, I will mean numbers like 10, 100, 1,000, 10,000, and so on. Okay, these are base numbers, and the relative base numbers of that will be 20, 200, 2,000, 200, 2,000 and 20,000 and so on. Okay, like that. Similarly, 30,000 and all the way till 9, right? So these are all base numbers, and we will use this very creatively. Okay, in Vedic maths, it's all lot using basic, 30, 40 and everything, right? It's all the way till there. What I'm telling is, we will start with the base numbers. I will be using a lot of these base. And you will understand that. You will slowly understand the concepts over a period of time. And when I mean, the other concept is complement. Okay, so when I have a number 100, right, and if I have a number 50, the complement of 100 is again 50. So if I have 40, the complement of 40 is, as a base of 100, it is 60. Okay, so it is the other side, right? So if I have, similarly, if I have 8 and I'm using a base of, the closest base, the complement is 2, right? So in everything, we just have to remember this base and complement. Okay, very simple concept. This is nothing rocket science. Okay, so all right. So similarly, what I've told here, see, if you have 83, what's the complement of 83? It is 17, right? You're looking at the other way around. So if I take a 100 rupee note and I'm just cutting it, so this part is 17 and this part is 83. That's all, right? So why I want to introduce this is, you will find this useful in trying to simplify some of our calculations in the I got your connect on LinkedIn. Yeah. All right. Okay, so let's find the complementary of 876. So what do I mean when I'm telling the complementary of 876? That means effectively I see more people joining. So it's good all of you join, but I hope you'll not miss out anything. So for those of you join later, it's going to be a little difficult to catch up. Anyway, complementary. Hi Devesh. All right, so complementary of 876. What's complementary of 876? Essentially, I'm doing 1000 minus 876, right? So there is one of the first sutras or so, if I may introduce, something called all from 9 last from 10. Okay, and those of you who have attended the previous classes, it's probably going to be a refresher for you. All from 9 last from 10 means that effectively to find the complementary of 876, yeah, complementary of 876, I only subtract this digit by 9, all the digits by 9, and the last one by 4, last one by 10. Okay, so that is why 9 minus 8 is a 1, 9 minus 7 is a 2, and 10 minus 6 is a 4, right? So this is all you're finding complementary. So it's essentially, if I ask you to do a subtraction of 1000 minus 3, 4, 5, what do? You take 9 minus 3, which is a 6, 9 minus 4, which is a 5, and 10 minus 5, which is a 5, right? In normal course, in your normal course also, you're doing the same thing, right? What do? You take a 0, you carry 1, you carry 1, carry 1 everywhere. You will be doing, you'll be drawing all this, and then you'll figure it out that it is 9 and then subtract it, right? So same thing. What I'm trying to say you is, when you are subtracting any number from a base, you simply use the sutra all from 9 last from 10. It sticks onto your head, right? All from 9 last from 10, right? So that's all. Similarly here, all this is the same here only. There's nothing different that I'm telling you. Okay. Similarly, one thing, if a complementary of a single digit number, there's nothing to subtract from 9, right? It is a direct subtraction from 10. That's all. So complementary of 6 is a 4, because 10 minus 6 is a 4, because that's the last digit, and the last digit is always from 10. Okay, the only one exception here is when you look at 470, and if something is ending in 0, the sutra doesn't apply to all the 3 numbers. The sutra only applies till here. All from 9, last from 10, right? So you don't do this. This is incorrect, right? So you apply the sutra only over here. You bring down the 0 as is, right? The 0 becomes here, and 9 minus 4 is a 5, 10 minus 7 is a 3. So the actual answer is 530, right? Okay, so will you tell me about 4 and 5 digit multiplication? Okay, we are only doing a pattern on 2 digit multiplication, but we'll see if we get time. We'll extend to 2, 3, 4 digits, but we'll see if we can come to it. Okay, all right. So when I'm telling about the subtraction, the same concept here, nothing great here. 1000 minus 864, all you do is all from 9 last from 10. Now suppose you have, you're short of some if you're looking at 1000 minus 77, you need to pad it up with zeros here. Okay, wherever you're short of the digits, all you pad it up from zeros and apply the sutra here. 9 minus 0 is a 9, 9 minus 7 is a 2, and 10 minus 7 is a 3. Okay, so the idea is, and you can experiment with this also, okay, over a period of time, and you get larger numbers to subtract. And it is not only for base numbers like these, we will extend it also. Okay, slowly, step by step, we will do some more subtraction. Okay, I hope it's very clear to you, right? Nothing complicated here, right? Very straightforward. All from 9, last from 10. That's all, right? I'll move forward. Okay, all right. Now, earlier example was, you had only a 1 here, all was base of 1 and all that, right? Once, everything was ones. Now what? I'm slowly extending that. Now what if I get 600 minus 77, right? The last one is, the first digit is always 1 less, right? See, basically what are you doing here? You're subtracting 600, 600s are there. Usme se you're subtracting 177. So 800 to gaya, right? So you will be left with 500s only, no? So that's all it is, right? So the last one is 5, and then again apply the sutra here. All from 9, last from 10, 523, right? Similarly, 5000 minus 123, all from 9, last from 10. This 5 becomes 1 less, right? So 4, apply the sutra. Now another variation of it. Suppose you get a number, another number. You can get any numbers, right? Suppose you get this. What this says is, and think about it logically also, okay? You have 8 thousands, out of which you need to subtract some 3000s, and then you need to subtract another 504 also. So one more 5000 will go. So every time you're actually subtracting. So when I do 8, what I'm saying is here, subtract one more than this, right? 8 minus 4. Subtract one more than this digit. 5 minus 2, 3. That is how you get it, right? But logically also, if you see up 8000, say you're subtracting 3504. So 8000, say 3000, if it goes, you're left with 5000s. And then from that 5000, you need to subtract one more 1000, right? So that's why it's becoming subtract one more than this number. So when you do that, then apply the sutra, odd from 9, last from 10, right? So now we'll look at it. We'll make it a little more interesting now, okay? We'll make it a little more interesting now. And we will do some polling as well to, okay. You know, we talked about base numbers. We talked about complement. We'll talk about one more concept called vinculum or bar numbers. Okay, this is how you represent the complement of a number, and we will go through this. Let me take you. Look at this clock here, right? When you look at this clock, you will tell the time is 6:50, right? 6:50 p.m. I can also tell that the time is 10 minutes to 7, right? 7 o'clock, say there are 10 minutes to 7, right? Or you say 6:50, both are the same, right? Both are exactly the same. So let me share my screen here, because I need to show some little bit of animation which I do. And when I share this on as a PDF, PowerPoint animation doesn't work. So let me take that PowerPoint animation. I have it open here. Let me play that for you. Okay. And let me share my screen. Hold on. Oh, yeah. Okay. Okay, it's just opening. Give me a minute. It was open, but it got closed. Okay. The same presentation is just that this is in the PowerPoint mode, and I want to play something for you. I can't see any of your chat windows now, but I'll come back to it. Okay. So I am trying to represent 19. Okay. When I represent 19, I can also say 19 is 20 minus 1, right? And I will represent 19 as 2 bar 1. Okay. It is a representation in Vedic Maths. The idea is that I will be able to simplify my numbers, ending in 9, 8, 7, right? Anything after 5 on a scale of 1 to 9, anything after 5, 5, 6, 7, 8, 9. When you get these numbers in your calculations, your calculation becomes a little more complicated, because you're dealing with larger numbers. So in Vedic Maths, there is always a concept that you will use a lot. It's called bar numbers or vinculum. So some of you may be familiar with it, but I'm just repeating. 18 can be represented as 20 minus 2. So 2 bar 2. Okay. 59 is represented as 6. 60 minus 1, 6 bar 1. 88 can be represented as 90 minus 2, 9 bar 2. Okay, minus 4. So when I ask you to convert something to its bar number form, you subtract it from its nearest base, right? You subtract the number from its nearest base and then see what it is, right? That's how we derive bar numbers. So similarly, if I have to convert from a bar number to a regular form, what do I do? 6 bar 1 will be called 60 minus 1, right? And 7 bar 2 will be called 70 minus 2, which is 68. 5 bar 3 is 50 minus 3, which is 47. Okay, now let's do some subtraction. Okay, I'm doing 83 minus 68. In your normal maths, right, what will you do? When you do 83 minus 68, you will take one carry from 8, you will put it on 13, you will subtract 13 minus 8, and you will get 5, right? And then whatever is left from there, 7 minus 6, you will get like that. So now what I'm going to tell you is, when you are doing subtraction, and this is especially when you have a small number on top and when you have a big number on bottom, you will do a small minus big. You can't do I mean, what we've been taught is you can't subtract a small minus big, right? What I'm going to tell you is, be bold and subtract that. You do 8 minus 3 here, but only one condition: you have to add a bar number on top, because you're subtracting from, a small number from, it's the opposite side, right? You take a big number and you subtract a small number, you can do a subtraction. But the other way around, and the concept is also very similar. Basically, you're subtracting, you're using that complements technique here. Okay, so when I write 83 minus 38, I will tell that I will do 8 minus 3 and I will put a bar sign, right? So everybody will like it, right? Okay, I don't have to think too much. This answer is 2 bar 5. Now if you remember the earlier representation, what it is, 20 minus 5, right? This one, 15, right? So now let's look at one more example. 567 minus 279. You have a small number on top, you have a big number on bottom, right? So 7 minus 9, I'm not going to worry about carry. No carries here, right? 9 minus 7 is a bar 2. 6 minus 7 is a bar 1. And 5 minus 2 is a normal subtraction. 5 minus 2 is 3. So now what is this? This is what? This is actually 300 minus 12. Now you don't need to do this 300 minus 12 also. Remember that all from 9 lasts from 10. Basically, you need to apply that only. When you do all from 9 lasts from 10, what do you get? You get what? First one you will reduce by 1. 9 minus 1 is 8. 10 minus 2 is 10 minus 2 is 8. Okay, you will be able to see, with practice you will be able to do it instantly. Okay, that's the whole idea. You'll be able to do it instantly. Let's look at a few. I'm not able to see your chat when I'm in this mode. I will come back and answer your questions on chat. Okay, but let me play this animation, because on PDF mena I can't play animations. Whatever I'm uploading to this one is PDF. So let's do one more example and I'll come back to you. Okay, so remember 543, 168. I do 3 and 8, it will be a bar 5. 4 and 6 will be a bar 2. 5 minus 1 will be a 4. So what it is, it's actually 400 minus 25. You don't need to apply the sutra also. Actually here, you know that it is answer is 375, right? 400 minus 25, right? Now you might be wondering, see, I already know how to do that other subtraction is okay, but where this method will help you is dealing with larger number subtractions. It will be a lot easier. When you have 0 and 9 and all that, you will find it, you will be doing it seamlessly, more faster. And I've proven this with my students also. A lot of my younger students in the 3rd grade, 4th grade, they are able to do subtraction like super fast. 37 minus 558, again bar 1, what it is, bar 2 and 2. So 200 minus 21. So you apply the sutra here also, or you do simple 200 minus 21. Right? I hope it's clear. Let's look at one more example before I come back to you all. There on that other screen on the chat window. So here again, 4 and 9, bar 5, bar 1, bar 3, and 3. Now there, some of you may have questioned, what if bar comes in between? We'll solve that also. I think I have one example where there is a bar number in between, then positive sign, and then negative sign. 3000 minus 315, right? I hope it's clear, right? Let me come back to the chat window and see what you guys are telling. Okay, I see that. Okay, yeah, okay, not a lot of problem, I think. Okay, clear, right? 3000 minus 315. It will come easier. Okay, it will come easier if you, even if you can teach others as well. A lot of benefit in Vedic Maths is, and I've told this to some of my students, and I know Ria, you're here. She teaches other, other of her, either her cousins or siblings. You will learn more. Okay, so 6453. Oops. Ah, so here, whatever. So 3 minus 1 is a 2. Easy peasy, right? 4 minus 8, bar 4, right? 5 minus 8, 3. See, you don't have to worry about that carry at all here. You're not worrying about carry at all here. Okay, 6 minus 2 is a 4. Now what do you do here? See, a positive nice number is come there, right? Bar number is there, positive number is there. Then you have one positive number. Simply what this means is, this is 400 minus 34. 2 ko you can drop it as is. 2 ko will stay there only, right? So apply the sutra there, right? So 2, if you see here, all you're simply doing is 400 minus 34. That's all, right? So 3662. Practice yourself. Take a pen and paper, and after this class, take any 2-digit number, whatever, 2, 10, whatever digit numbers. You take a 10-digit number and subtract. Also, you will be able to do it much faster. That's one challenge that I can give you. Take a 10-digit number, subtract 2 10-digit numbers, and see, you will get it. The results. Use the same sutra method, and you will be able to do it faster. Okay. Oh, that's time for a poll. One second. Let me just set this up. Let me stop sharing. Sorry, I had to set something on a poll now. I'm going to give you a poll. Okay. So let's do some quick practice. We have about 10 practice questions across all the things. Use the sutra all from 9, last from 10, right? Don't use your other method, okay? I'm saying don't use carry and all that. Use normal, all from 9, last from 10, okay? I think most of it's very easy question, right? Some of you got D. Some of you got B. Most of you got B. Okay. All right, let's check it out. Let's check it out. All from 9, last from 10, right? All from 9. So 9 minus 6 is a 3. 9 minus 3 is a 6. 9 minus 4 is a 5. 10 minus 6 is a 4, right? All from 9, last from 10. Okay, let's do one more. Remember, when you are short of numbers, you pad it up with a 0, okay? Do it aram se, okay? Remember, yeah, some of you have forgotten that 0, okay? You need to subtract that, you need to put that 0 there. Ignore this, by mistake. Ignore this. Okay, I think we are done. Some of you got it wrong. Why? Let's look at it. Why is the leaderboard not coming? Okay, so as I said, when you're short, you have 1, 2, 3, 4, 5 zeros. No? So you have only 4 digits. So you need to pad it up with remaining number of 0. So here this becomes a 9. 9 minus 3 becomes a 6. 9 minus 8 becomes a 1. 9 minus 9 becomes a 0. And 10 minus 4 becomes a 6. Right? So the answer is D. Right? Let's move forward with rapid fire. Quickly. Use the bar number concept here now, okay? Use the bar number concept. Remember, big minus small and small minus big. It's a good refresher for those who have attended before. What's happening to the others? Okay. Why did some of you get B? Okay, let's look at it, okay? Explain, I'm forgetting. Okay, no problem. No problem. So 6 minus, remember this is, let me write this, okay? Last time I wrote this and some of you understood like that way, okay? This is small and this is big. Okay, when I'm writing S means small and B is big, okay? Because this is bigger relatively between these two numbers. This is small, this is big, and this is big, and this is small. Big minus small is easy, no? 2. Small minus big. So 5 minus 6, what will I write? I will write it as a bar 1. 4 minus 6, this is small, this is big, so I will write it as a bar 2. 3 minus 2 is easy peasy, 3 minus 2 is a 1. The answer is 1, bar 2, bar 1, 2. So what does this mean actually? It is 100 minus 21 followed by 2, right? Yeah, perfect. That's what it is. So 0, 9 minus 2 is a 7, 10 minus 1 is a 9. Yeah. So 0, 7, 9, 2. Don't forget the 2. 2 is there, no? 2 to is always left there, right? That's what it is. Simple. Nothing great here, right? Okay. Let's do one more. Last one in this series. Slightly bigger number. Oh. 1 second. Oh. Sorry. This is my first question, second question, third question, fourth question, right? Yeah. We are doing this now, no? Add the sequence incorrect. Remember when you had this, you had to subtract by 1 more than that number down below. Okay. I mean, the whole idea of practice here is to ensure that you revise what you learned. Okay, I think Manan, Josmi. I don't know, what about the others? You didn't attempt. Why? Okay. 8 minus 6. So what, remember what I told you, when you subtract this, right, you're effectively need to subtract 8 minus by 1 more than 6. So what is 1 more than 6? 7, right? Right, now apply. So then 4 minus 8. Okay, sorry, huh? Maybe I'm my bad. No. Let me do it this way. Let me do it from right to left. 6 minus 4 is a 2. 5 minus 6 is a bar 1, right? And 4 minus 8 is a bar 4. And 8 minus 6 is a regular 2, right? So this is about 200 minus 41 and 2, right? So when I use the sutra, all from 9, last from 10, what this becomes? 2 becomes a 1. 9 minus 4 becomes a 5. 10 minus 1 becomes a 9. And 2, 1592. Okay, I'm doing it in 2 steps. Actually, when you practice it, what is LBD? I didn't understand the full form. Okay, and 1592. Okay, leaderboard. Leaderboard. Why is the leaderboard not coming? Maybe when not lot of people are attending it, leaderboard doesn't come, is it? Maybe it will come at the end. Okay, I have seen that sometimes. Okay, okay, we'll go forward to the next question. Oh, okay. So we are done with subtraction. This is a quick so on subtraction. Now you can practice more. You will be faster at subtraction, right? Let's quickly cover multiplication because we have some ways to go. Okay, so this is a concept of base multiplication. Let me share my screen quickly. I hope we get time. See, this is why I wanted to rush. I try to put as much topics as possible to benefit you all in 1 hour, but that means that I have to do it faster also. Okay, so maybe I have to skip some whole next time. Okay, so I told you about base numbers in Vedic Maths, right? 10, 100,000. So we will use that same concept to do multiplication. Simple and easy method to do multiplication. I'm doing 12 into 13. How much is 12 greater than 10? My nearest base is 2. And this method you may have seen many places. Some of you would have told you and all that. I will also explain with some proof of why this method works. Okay. So 12 into 13. How much is 12 greater than 10? And how much is 13 greater than 10 is 3, right? So now what do? Is I multiply 2 and 3 vertically. I get 6. That's my last part of the answer. The first part of the answer is adding it crosswise. If you see here, adding it crosswise, 12 plus 3, right? 156. That's my answer, right? So 17 into 13. Now you can guess it, right? 7 into 3 is a 21. But remember, I have to put a carry here because that's a units place and I'm actually having a tens now. That tens need to go, the other side. 17 plus 3 is 20. When that 2 goes over here, it becomes a 221. That's my answer, right? Similarly 16 into 12. Oops. Why is that animation not playing? So 6 into 2, 12, 16 plus 2, 18. And you can cross multiply either way, okay? You can do 16 plus 2 or 12 plus 6. The answer is going to be the same only, 18. So we get 192. That's the answer. So simple concept of base multiplication. Similarly, if it is above or below the base, right? In all these cases, it was above the base, right? Sometimes it is below, it can be below the base also. And you have to decide here, 88 and 98, what's my base is 100. Okay, there are variations to this also. One number can be with a different base, the other number can be with a different base. That also we'll try to cover. Yeah, okay. Here I'm doing a base of 100. So 100 minus 88 is what? What is a deficiency from the base? How much it is less than the base? It is 12. 98 is how much less than the base? 2. Right? So I will treat it with a minus sign. Okay, and I like to use it with a minus sign because it's a deficiency. It's negative, something negative, right? So when I multiply 12 into 2, I get a 24, right? But here I'm not having a carry here. Remember, I'm using a base of 100, right? So I am allowed 2 digits, right? It's a base of 100. If it was 3 digits, if it was only one digit in a base, I am allowed only 1 digit. So 88 minus 2 is 86, right? 88 minus 2, 86. Or you can do a 98 minus 12 also. I like to do 88 minus 2 because it's easier, no, than compared to 98 minus 12, right? Similarly, 96 into 82, right? 82 minus 4, 4 into 18, 72, right? You can try it with, after this class, you can try more numbers closer to a base and you will get the same answer, right? 12 into 5 is a 60, 88 minus 5 is a 83. Very simple, right? So you can do the same thing with bases of 100, 1000, and you have to decide. Of course, these are best used when the number is very close to the base. Okay, you have other method also, and I will tell you general method where you don't need to depend on the base, but a general method which will apply for all scenarios. But use your method very smartly. You can use the base method when the number is close to the base. Why this works geometrically, I will try to explain now, but it takes a little while, and I'm a little worried that we have only 15 minutes left in our class, and we have division also to cover, a little more of multiplication. But this is rough thing, and you can see this in the download the PDF. It is always going to be available, and this is how it is geometrically. It is proven that this method works because you consider you're drawing a square of 100 by 100. 88 into 98 means you're trying to find the area of that square. Then when you're taking a base of 100, basically you find the whole area, you subtract it, you will get it. But I don't want to go into it because we don't have time now. I want to cover more important concepts. But these are all written out there. If you go through it sometime, you will be able to understand. Even geometrically also, algebraically also, some of you are aware of algebra. When you're doing two numbers, you can represent it as x minus a and x minus b. And then you will see that x squared minus, ultimately this comes up the same thing actually. Okay. So that's how it works. So same concept as before. Base above 100 means you will do it there. I think I had taken a base of. So now proportionately also there's something called, if it's a base of 200, what you will do? Base of 300, 400, we'll do that also. Okay, so let me quickly skip through this and cover that proportionately, because this I hope is all very clear and straightforward. Okay. What if the number is above and below the base? This is interesting, right? One number is above the base, the other number is below the base. So I will write a +2 and -2, right? So what it will become? It will become a -4. But remember, this will be with a bar sign. This is where your bar sign will be useful. Okay, so 102 minus 2 is 100. So now what this effectively means is basically, how did I do this? 9966, 9996. See, you can think it of like this as well. You give 100 away here. Right, when you give off 100 here, you will be left with 99 hundreds, right? And then when you're subtracting 100 minus 4, you're left with 96. Okay, look at this example. 60, 9360. So basically you can write it as 93. You can write it as 93 bar 6 bar 0, right? And then apply that sutra, you will get the same answer that we did before. When you apply that sutra, you will get 92. But remember, 0 will come down. The sutra will apply only on 6. 10 minus 6 is a 4. 3 will become a 2. Okay, in this case, see here, all from 9, last from 10. 9 minus 0 is a 9. 10 minus 4 is a 6. Right? But this is a base of, basically you're doing 1000. 4 zeros minus 04. This was, if I can write it, can I write it here? So this is basically minus 04. This is what you're doing, right? So you're padding up with zeros. 9, 9, 9, 6. That's how we got this, right? Simple. 32, 104 minus bar. So this one will be, again, you will apply that sutra. 1, 0, 3. 9 minus 3 is a 6. And 10 minus 2 is a 8, right? Proportionately. Okay, suppose the number is, you can extend this, to other, bases as well. Suppose it is 200. So what you will do here, Same thing, you will do the same thing. Only one difference is you will add a 213 plus 3, right? The answer is not 21639 because you're using a base of 200. Earlier my base was 100. You need to double this. You need to double this, 43239. So let me come back to the chat screen. Okay, I hope it's all clear. Yeah. Okay. Look at this method now. 29 into 28. I'm going to use a base of 30. 29 minus 30 minus 29 is 1, right? So 30 minus 28 is, sorry. So when I use a base of 30, I will multiply it by 3, right? 3. So I will 27 into 3, 812, right? So 33 into 34. You can guess the base, right? The base is 30, right? I will add 33 plus 4. It will become a 37. I will multiply it by a 3. There's a carry. When there is a carry, you will add the carry after you do the multiplication. Okay, after the multiplier is applied. Okay, there is something with a different base, but let me skip this now because I have to cover. So the concept of base multiplication, right, is very simple. It's just using a base number and you're finding the deficiency, you're handling the deficiency, multiplying the deficiency and doing a cross multiplication to get the result. That's all. The concept is quick multiplication now, okay, vertically and crosswise. This is one of the most beautiful methods. There's another beautiful method of division as well. I hope we can get to it, but division, quickly multiplication. Okay, your traditional method is there on your left side. Okay, your Vedic Maths method is on your right side here. Follow the color codes here, right? What I've written in the last, this pattern that you see here, and this is something that you will use a lot in multiplication. This means you're vertically multiplying. 4 into 2 is 8. This red color means you're multiplying and adding crosswise, right? So 4 into 2 is an 8. Then you multiply and add crosswise. So what is a 2 into 2 is a 4 plus 4 into 1 is a 4, which is 8, which is what you've written here. And the last one is 2 into 1. What you're effectively doing here now, you're multiplying to find out the units place. You're multiplying both the units place. You will get the units place. To find out the tens place, you're multiplying the tens by ones. And this 10 by this one. And then you're effectively finding the tens place. To find the hundreds place, what are you doing? When you multiply a tens and a tens place, you get a hundreds, right? 10 in tens place into tens place, you get 100. That's what. The normal method, what you're doing here, you're doing 1 by 1, right? You're multiplying both this by 1, both the same thing. It is not very, it is, you're getting the same result. But with longer numbers, larger numbers, your multiplication process will be faster when you apply it in this sequence, right? So it's an intelligent way of doing things, and you will see that in division as well. Let's look at a few more examples. Remember this pattern, vertically into crosswise. When you have to have the carry, you have to always handle the carry, right? Carry, you cannot write 3 into 34 into 83, right? So 4 into 3 is a 12, right? That's in the units place. This is a tens place. So it needs to go to the tens, right? So 12. 3 in middle is 3 into 3, 9, plus 8 into 4 is 32. So 41, right? 41. So now this 1 becomes 1 plus 1 becomes a 2, and this 4 gets carried over here. This will become a 28. 3 into 4 is 28. So that's it. 2822. Okay, can we do a quick poll? Just one question for a poll now, because we only have time for that. And so at least I can assure myself that you understood the concept here. Okay, so let's go here. Stop sharing. Keeping in mind, question 8, right? We'll do this. So do it. The thing is that you have to do this mentally. Okay, you need to start writing it mentally, one by one, right? When you do such problems, you start doing it mentally, right? One digit at a time. So 3, I think most of you got it. Oh, I think everyone's got it right, huh? Very good. Let me end the poll. Now the leaderboard has come. I hope it's all clear to you. Mannan, Josmi, Kashish, Ansh, Udit, Shantanu. Some of you just attended one question, but it's okay. No pressure. So I think all of you got it clear. No wrong answers. But the idea is when you start doing it mentally, think in your mind 1 into 3 is 3, and then the other one 2 into 3 is 6 plus 2 8, and the last one is 4. Yeah, you need to learn division. You will really appreciate the true power of Vedic maths in division. Okay, that's why this is called the crowning gem method. We have only 5 minutes. Oh my god, I wish I had more time. Okay, no problem. Okay, so anyway, this is a quick crash course kind of thing. Okay, so it's not. So I'm dividing 209. Am I allowed to extend the class? Are you all willing to stay another 10 minutes? 10 minutes will be worth it. Okay. Extend time is not come yet. It will prompt me that time I will extend. Okay, I'm dividing 209 divided by 52. Okay, so just understand that whenever you do division, your what right? Your what is division? Fundamentals of division is if you're doing 209 divided by 52. I'm trying to find out how many 52s are there in 209. How many perfect